We know what parallel lines are. We've just talked about that. Parallel lines are two.
Oh, that's a new part of it. I don't remember parallel lines have to be on the same plane.
Yeah, that's why we're talking about that specifically now in this section. So parallel lines are two lines that do not intersect, which is what we have talked about. Put your hand down. But what we're going to specifically talk about is that they need to be on the same plane. So they're going to be coplanar. So two lines that do not intersect and are coplanar. I think this was yours, wasn't it?
Oh, cool. You do your math there.
So
All right.
This table is a plane.
Yeah, so your tabletop is a plane.
Imagine a pencil here. I don't have nothing to do with a pencil here.
Yep, so those would be parallel lines on the same plane. Okay, so if we think about lines in this room, guys, 20
draw some
minutes.
lines on the whiteboard.
If we think about this line right here, that would be parallel to this line right here, right? It should be parallel to this line right here, to this line right here, this line right here. Would this line be parallel to, let's say, a line, if I drew a line directly below it on the floor? So right here, and I drew a line right here. Would they still be parallel? Could I technically put a plane through those, the two of them? Yeah, even though there physically is not a plane right now, I could construct a wall and plop it right there, right? If I wanted to, I'm not going to. What if I move the line to right here? Am I still parallel to it?
No.
Could I get a piece of plywood and
You could,
connect
but it
there
wouldn't be-
to here? It would just be on a diagonal. It would be a diagonal plane,
Right.
right? So those will still be parallel. How about, let's think about that line on that wall. Is that parallel to the similar line on that wall?
Yeah.
Yeah, they're parallel. They never intersect.
Because there could be a plane.
They could have a plane going through them. Would that line on that wall be parallel to this line right here on the ceiling? Yes. Okay. So parallel lines don't necessarily need to be on the same visual plane, but as long as they're going the same direction, I could technically put a plane through them. And that's what gets us to the difference between parallel lines and skew lines.
I'm confused.
Skew lines are two lines that never intersect. So that sounds similar to what a parallel line is like. Two lines that never intersect. But in this case, for skew lines, they are not coplanar. So they are not going to be in the same plane. Dominic, what's your question?
How can they not be coplanar? We can confirm that pretty much any set of lines that go the same direction
Right, so I'm going to show you an example of skew lines. So let's think about this line over here again on the side wall. Now think about this line that goes in this direction in the ceiling. Will those lines ever intersect?
Wait, what?
Will this line right here, right above me, ever intersect with that dent line in the wall?
Well, yeah, they are.
This one's higher, right?
Oh.
If it kept going, it would go above that line, right? So they would not be on the same plane, and they would never intersect. So skew lines are lines that go in opposite direction,
It might be
but
helpful
never
to
intersect.
have a yardstick for like where your lines are. 'Cause it's-
You can't see that line. That one right there.
Oh, you were putting. I think you were putting one in the air.
No, that one right there.
Oh,
Physically talking about that line. But
Does a plane have to be straight?
no, it'd be on a
So
diagonal.
you can go.
Well, it can be on an angle. It can't go wavy.
What would a wavy thing be?
Nothing. All right, parallel planes
Like
are two planes that do not intersect. Okay, Dominic, we're done with it.
like this.
We're done with it. That's not a plane. That's two different planes. So if we think about the room, what plane would be parallel to the ceiling? The floor. What plane would be parallel to the front wall? The back wall. What plane would be parallel to this side wall? The other side wall. Okay? So if we look at the first example with this diagram, we got a cube. We got some points, we've got some planes, we've got some sides. So planes, we've got the front plane, we've got the back side, we've got the right side, we've got the left side, we've got the top, we've got the bottom. Then we have a bunch of lines. Where are my parallel lines at? Well, AD would be parallel to BC. Would AD also be parallel to EH?
Yes.
Yes, they're going in the same direction, they never intersect. Would AD be parallel to FG?
No,
Are they going in the same direction, never intersecting?
I can't see.
Yeah.
Yes, AD would go from left to right, FG would go from left to right. Just so happens that they're not on the same plane on the box, but if I put a plane directly through diagonally, then they would be. What about skew lines? AB is going from front to back. Can someone give me a line that's going from side to side that would never intersect with AB? HG is going the same direction, it's still going front to back. FG is going right to left, that would be a skew line, and EH would also be another skew line. Would DG be a skew line with AB?
No,
Is it going in a different direction and never intersecting?
it moves.
Huh?
It intersects.
It would? If this is my box, I don't have any boxes
Oh,
for my
no,
box.
it wouldn't.
If this was my box, and I had this line going in this direction, right? And this line going in that direction, would they ever intersect? No. Okay? Alright, so for this example, it's being more specific. It wants the line parallel to AB that contains point D. So which line is parallel to AB containing point D? Good. DC is your answer. So line DC. I don't think there's any other options for containing point D. So those two lines would be parallel. Part B. Line skew to AB containing point D. DG.
DH would work.
So even though DG technically on a flat surface intersects, it would never intersect. So DG, and then the other one was what? DH? Yeah. DH would be skewed. Going in opposite directions, never intersecting. Part C. Line perpendicular to AB containing point, this should be point D, not A. It's a typo. Which line is perpendicular to AB containing point D? Yeah, DA would be perpendicular. Because it's a cube, we know that that's a right angle. So DA. And then D, what plane is parallel to EFG containing point A? So EFG is the bottom. Yep, so we go up to the top, ABC. Only 3 points to name a plane, so just pick 3 of them.
I was being creative.
ABC.
That's the craziest shape I've ever seen.
All right, once you have that, flip on to the back. So now we know how to identify parallel lines, skew lines, perpendicular lines, parallel planes. So now what we're going to be looking at, head up, Jimmy, please, is what happens when we have 2 lines and we put a line that cuts through them. Well, that line has a special name, and it's called a transversal. So a transversal is a line that intersects 2 or more coplanar lines at different points.
Jimmy, we've seen these before in different questions in the past.
Yeah. So if I had, don't put this on your notes, just watch. If I have 2 lines, doesn't matter what direction they're going in, doesn't matter if they would ever intersect, those 2 lines. And if I had 1 line that intersected those 2 lines at 2 different points, that becomes the transversal. Now if we look at this diagram, how many angles are created?
1, 2,
Well, up top we have how many angles? 4. So we have angle 1, 2, 3, and 4. Down the bottom we have 4. So 5, 6, 7, 8. So when we have a transversal cutting 2 lines, we have a total of how many angles?
I
8.
see. I found a good way to remember it. You can just remember it by the amount of lines that it cuts through times 4.
Sure.
Since it's like 2 lines, it would be 8. If it was 1 line, it would be 4. I'm guessing
Right.
3 would be like 12.
That would work.
That was my favorite line.
All right, so our first type of angle relationship, Dominic, stop.
Didn't even look at the tire.
Our first type of angle relationship is what's called corresponding angles. From the top left box of that grid, corresponding angles. So corresponding angles, what are they? They are 2 angles having corresponding positions. So right now I have labeled angle 1 and angle 5 because that would be an example of corresponding angles. So I want you to label 1 and 5. Now notice, out of those 8 angles, angle 1 is the top left angle of this set of 4. If I go down to this set of 4, 5 is the top left angle in that set of 4. Dominic, put your hand down. I'm talking. So if I put the rest in, don't do this on your notes, just watch. If I put in, let's go red, 2, 3, 4, 5, 6, 7, 8. What do you think would correspond with 2? 6. What would correspond with 4? 8. What would correspond with 7? 3. Okay, so they're in the same position when you think about these as a set of 4 and these as a set of 4. Okay, corresponding. So you have 4 sets of corresponding angles. The next one we have is alternate interior angles. And these are a lot of words, so write small. Alternate interior angles, I would abbreviate to. So when you have 2 angles that lie between the 2 lines and on opposite sides of the transversal. So label 4 and 5 because that would be an example of alternate interior angles. So now we need to first think about what interior means. If I think about the interior of these 2 lines, does everybody see how the green area would be interior? Yes? If I think about exterior, notice how the orange is the exterior. So if I were to label the rest of my numbers, 1, 2, 3, 4, 5, 6, 7, 8, what are the 4 angles that are in the interior? 3, 4, 5, and 6, right? So for them to be alternate interior, they need to be on the opposite side of the transversal. So they're alternating sides, and they're on the interior. Yes?
For like tests, are you gonna have us like kind of like 1, 2, 3, 4, or?
They'll already be labeled, and then you'll have to find the pair of them.
Oh.
Like if I had this up here and I would say, identify what 3 and 6 is, then you would say it's an alternate interior.
So we're not gonna have to
Or it would be identify a set of alternate interior angles. Then you would say 3 and 6, 5 and 4. So what angles would be on the exterior? 1, 2, 8, and 7. Can someone take a guess what the alternate exterior angles would be? Alexis?
1 and 7 and 2.
1 and 7, 2 and 8. Okay, which is what the next one is. I would not rewrite all these words again because it's exactly of what you just wrote. I would just put down outside and opposite would be the only words I would write if I were taking notes right now. It's just the same thing. So it's outside and opposite. Unless you feel like rewriting all those words again. So 1 and 8 are alternate exterior angles. Okay. And then the last one we have is what's called consecutive interior. What does the word consecutive mean?
You know, like in a row, like in order.
Yeah, so if I asked for consecutive numbers, what would you give me?
4, 5, 6,
7, 8. Those are consecutive numbers. They're right next to each other. So if I had to do consecutive interior, let me put all these up again. Oops, that was in highlighter mode. 2, 3, 4, 5, 6, 7, 8. Which angles do you think would be the consecutive interior?
3, 4, 5, 6.
Wait.
Well, it's a pair.
Oh, 3, 4.
Oh, see,
4, 5, and 6.
3 and 4 are a linear pair. 5 and 6 are a linear pair.
4 and 6.
4 and 5. They're on the same side inside. 3 and 6, same side inside.
excuse me.
So, our consecutive interior angles, it's when you have two angles that lie between the two lines. So, two angles that lie between the two lines and on the same sides of the transversal.
So we can remember this by between and same side.
Consecutive. Excuse me?
He's writing on the note. Poked him with a pen.
Well, don't poke him with a pen and don't swear in my classroom. Okay, so 4 and 6 up there would be an example of consecutive interior angles. Okay, over here, these would be your other set of consecutive interior angles. All right, so if we look at the example down on the bottom, we need to find all of our matches. Give me a set of corresponding angles. Now be careful. Here's your set of 4 and here's your set of 4. So you're finding one from the left and finding one from the right. So one would be with corresponding 5. 1 is upper left, 5 is upper left. That's my and sign, or and. Use whatever and sign you want. What would be corresponding with 2?
2 and 6.
Good. So 2 and 6. What would be corresponding with 3? 7. And then 4 and 8 would be all of your corresponding angles. Let's go. Head up. If you don't put your head on your desk, then you won't be tempted to fall asleep. For B, we're looking for alternate interior angles. So that means we have to be on the interior alternating sides. Give me one set. 4 and 5 would work.
So 2 and 7.
And then 2 and 7. Those are your only interior angles, so they're your only ones that are going to work. C, alternate exterior. So now I got to be on the exterior, and alternating. So give me one set. 1 and 8. So angle 1 and angle 8, along with 3 and 6. Good. Last one, consecutive interior. Two and what? Good. 2 and angle 5. 4 and 7. Good. Questions?